Hey guys, this video we're going to be looking at how we can find the area of a circle or a sector. So this is kind of following on with the video on triangles and quadrilaterals. So you may remember that when we're finding the area of a circle or sector or doing any kind of measurement, it's always going to relate to this symbol here, pi. All right, pi, if you remember, is 3.1415. It's an infinitely long number, and we use it whenever we're working with circles. You don't need to remember that number. As long as you know where to access it on your calculator and put it into a formula, you're good to go. So we have our circle, first of all, and the main thing we're going to need when we've got our circle is our radius. Remember that the radius, that's what R stands for, is the distance between the center and the edge of the circle, the circumference. We could also sometimes have the diameter, and that's when there's a line going all the way across, and you would remember that the radius is equal to half the diameter. Okay? So for example, if the diameter of a circle is 20 centimeters, we'd need to know that when we're applying this formula that we have down here, area equals pi times r squared, that we need to halve the diameter to find the radius first. We'll see that in an example in a second. But yeah, so the formula for this, find the area of a circle, is pi times radius squared. Just put that in your calculator, find what the radius is, put it in the calculator, and you're good to go. As for a sector is essentially just a cutout of your circle. So it's still, that's like the center of the circle, and we're going to have two radii going either side. So we're still going to have the radius of the circle. The only other thing that's going to be added into the previous calculation is we're now going to have an angle between those two radii. That symbol there, if you remember it, is theta. All right. Theta is just a symbol that we use when we're talking about angles. Okay. So what we're really saying here is whatever angle is made between the two radii, we're going to call that theta. We divide that by 360, dividing by 360 because that's how many degrees there are in a whole shape. And then you see the rest is just pi r squared, which was the same as the area of a whole circle. So what we're seeing here really is we're just finding a fraction of that whole circle. So let's go through some examples. Looking at this first one, we see that we're told the diameter of this circle. So we can't just do pi times 15 squared. We just need to take a step back and think about, well, what's the radius? So the radius would be half of 15, which is 7.5, making sure we're doing that first. Now that I've got the radius is 7.5, I just put into my formula, the area equals pi times 7.5 squared, and we put that in pi times 7.5 squared, and this gives me 176.714586, blah, 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 blah. Because pi is what we call an irrational number, the number goes on forever and there is no pattern, all our answers are going to have like an infinitely long amount of decimals afterwards. So let's just round these to two decimal places. So we have 176.71, and again, looking that our units was in centimeters, so now we've got centimeters squared. There we go. Looking at this next example, we have two numbers now. We have this angle in here. We're being told that the angle between those two radii is 130. So here we can say that theta equals 130. And then we also have the radius here, which we're just told the radius is 2. So putting this into our formula for sector, it's the exact same, pi times r squared, except there's the 130 over 360 before we do pi times the radius squared. Again, we can put this into our calculator. So 130 over 360 times pi times 2 squared. We'll put that in, and this gives me 4.53785 ... And then to two decimal places, this would be 4.54 meters squared. Lastly, looking at this one, this is a semicircle. First of all, we note that, again, we'd be given the diameter as the distance the whole way across. So that means my radius is equal to 5. Okay. Now, there's two ways of approaching this. I could kind of visualize the whole circle, find the area of the whole circle, and then just halve it at the end, and that would work. Or we can treat this as a sector where this is a straight line. And so because it's a straight line, we know that this angle here would be 180 degrees, and that's what my theta would be. So theta is 180 degrees. So if we put this into our formula, we have area equals 180 over 360. We times it by pi. We times it by 5 squared. And once we put that in, so 180 over 360 times pi times 5 squared, this gives me 39.2699908 ... And then we can round this to be 27, and then meters squared. So that's that. You see that all that comes down to is the formula pi times the radius squared, and we're doing a sector. You just need to put a fraction in front of it, which will be the angle between the two radii, divide by 360, and then pi r squared. Thank you for watching.